Good day and welcome to the Math Salon. I'm Dr. Anumendem. Today we are going to look at the equation of lines. We already saw previously some equation of lines ideas, but now this will be the vector form of equation of lines and some few other things that usually come in the exams. Vectors are usually things that students don't like very often, but I think it's not really difficult. You just need to have a bit of patience and understand the concept. So we'll look at this example, and I hope that there you'll be able to get some tricks to be able to handle questions that are similar to these ones. So the question says, the vector equation of the lines L1 and L2 are given as r equal to I minus j plus 3k plus lambda I minus j plus k, and r are given also as this, where alpha, lambda, beta are real constants there. And given that L1 intersects L2, we are asked to look for these three to solve the three equations here. So first, look for the value of this alpha here, then the position vector of the point of intersection, we are told they intersect, and then the cosine of the angle. If they intersect, then there's an angle, the acute angle between the lines. Same, acute angle. In order to be able to solve this question, I would like that we go back a little, look at a recap about the equation of lines. And I will start. Let's just say that we have our Cartesian coordinates like that. Normally I have I, j, and k. I will just only show 2 for completeness. Don't worry. If it's 3, the vector will be a vector, just that it has 3 components. So let's just say we have a line. A line normally is set of points, a large number of them, and it's always infinite. If you have a line limited between 2 points A and B, then there's a line segment. If not, a line is infinite, just an infinite amount of points. So you just limit it to the space of your book or your page on which you're working. Like this case, my board, I will just limit the line. That does not mean it ends here, it continues. So if I have a line like this, and that the line passes through a point, because when an equation of line is given to you, this first part here is the position vector of the point on the line L1. And this is the position vector of a point on the line L2. This is a direction vector. So this is a vector that's going to be parallel to the line L1. And this is a vector that's also parallel to the line L2. And this just gives you a certain amount. We would have learned in the past, you already knew that if two vectors A and B are parallel, that means A can be written as a multiple of B. That's the way we look at it. If two vectors are parallel, the one can be expressed as a multiple of the other. So we would also use the same idea here. But we'll come to that. So let's say there's a point here A. The line is passing through that point. And we say that the position vector of that is A, C. We want to describe the points that lie on the line. If you can get an equation that describes all the points that lie on that line, that equation will be called the equation of the line. And if it is in vector form like it will be, we will call it the vector equation of the line. So let's say that a point P here, which could be anywhere else on this line, we want to describe it. That point P is a general point. We don't have sufficient information. We need to at least know the direction in which we want to describe this information. So let's say that we are given a vector V which is parallel to our line. If V is parallel to our line, then it's good. If I'm given a general position P, then I also know that the position vector of that general point is R. Let's call it, let's say the position vector of the general point. It could be here, it could be anywhere. We just call it OP, it's called R. So let's say now the point is here, and I want to describe this point here. Since I don't know, I have to use information I know. I know the position vector of the point A, and I know that my line is parallel to that. If that is the case, then my OP vector, this vector OP, would be equal to this road I don't know. So I use a road that I know. I would make this in that direction. So then this is OA plus AP. So I'll say OA plus AP. My OA is A, the small a that we saw. OP is R. My problem is now with AP. This AP is parallel to this. So it means the direction vector of this is a multiple of that, according to what we see here. So I can write this as lambda V. See? So this is the equation of a line that describes any point that lies on this. So any point here will satisfy this equation. So we call this the vector equation of a line, where the first vector here is the position vector of the point on the line, and the second one is a vector that is parallel to the line. And then this is, of course, following our principle that we learned there. If two vectors are parallel, the one is a multiple of the other. So if that is the case here, then we sure this has reminded us a little. Sometimes you may not have this given, but you are given 2 points on the line. For example, let's say that they said there's another point here called B, and it has a position vector OB. So it means I can look for the vector AB. The vector AB, you will see from A to B, if you don't know the road, you have to come down. So my AB vector, this will be the direction there. AB vector is AO plus OB. AO plus OB. But we don't know AO. We know OA. But that is the opposite direction. So this is minus OA plus OB. So if I assume that this was B, then this is simply minus A plus B. And this is simply B minus A. And this will be a vector that is parallel to our line. So we will replace it here. So for that version, my arrow now will be equal to, still it starts with the point A there, plus, now I don't have anything given there, lambda times, I have a direction vector that I just created with A and B, which is that, B minus A. So we say this is the equation of a line when you are given 2 points on the line. This is the equation of a line where you are given 1 point and a vector which is parallel to the line. We go to the equation that concerns us now. That was just a recap. So our question says these two intersect. That's what we know. Given that they intersect, given the L1 and L2 intersect, these two should be the same. So if I have two lines like that and they intersect, it means that they satisfy the equation of the line. Let me say this is L1 and this is L2. That these points satisfy both. So at that point, both of them should be the same. And that's what we try to do here. So if that is the case, I will write this left-hand side. This is I here minus j plus 3k plus lambda into I minus j plus k is equal to this one, 2i plus alpha j plus 6k plus mu into 2i plus j plus 3k. What is left now is, if two vectors are the same, means that, yeah, the coefficients of their corresponding unit vectors should be the same. The I, j, and k are unit vectors. So I will try to combine to fix it. We're in the salon. We have to make it look beautiful. So we try to gather the hair that have the same length together and fix them. Or those that are out of shape, we fix them. To do that here, then what I will do is, this I here has 1 as coefficient, plus this other I here, if I open this, it has lambda. So I keep the I outside. This is minus 1. And this lambda term, that is minus lambda. My j is outside, plus. This is 3, plus lambda. K is outside because this lambda times 1. This should be equal to, I do the same thing here. 2 here, plus 2 mu, 2 times mu, I, plus alpha here. Mu times 1 is just mu. J, plus here, 6, plus 3 mu, K. So at this point, what we have to do is equate the corresponding coefficients of the unit vectors on the left and that on the right. So the I and the I go together, the J and the J and the K and the K. So in that case, we have lambda, 1 plus lambda is equal to 2 plus mu, 2 mu, 2 plus 2 mu, minus 1 minus lambda is equal to alpha plus mu. 3 plus lambda is equal to 6 plus 3 mu. So this is equation 1, equation 2, equation 3. These are 3 simultaneous equations to solve, And we are left to choose how we want to do it. But I think the easiest way here is elimination. So I would subtract, I would take 1 minus 2. So equation 1 minus equation 2. If I do that here, 1 minus 3 is minus 2. Lambda minus lambda, it falls off. 2 minus 6 is minus 4. 2 mu minus 3 mu is minus mu. I can take minus 4 to this side, then I get minus 2 plus 4 is equal to minus mu. This is 2 is equal to minus mu. I can multiply both sides by minus 1 to get mu positive, and then this implies that my mu, so minus 2 is equal to mu. So we already have one component there. I can substitute in equation 1. Substitute mu equal to minus 2 in 1. If I do that, I get the 1 plus lambda is equal to 2 times, 2 plus 2 times minus 2, and that is equal to 2 minus 4, and that's minus 2. So my lambda is equal to minus 2 minus 1. Take this one to this side, and becomes minus 3. Since I have lambda here and mu, I can put it in equation 2 in order to get alpha. So substitute lambda and mu in equation 2. If I do that in equation 2, I have minus 1. Lambda is minus 3, so that's minus minus 3. Should be equal to alpha. Mu is minus 2, minus 2. If I fix it, this is minus 1 plus 3 is equal to lambda minus 2. If I add this together, this is 2. It's got alpha minus 2. Take minus 2 to this side, it becomes plus 2, so that's 4. So alpha is equal to 4. So for the first question there, alpha is equal to 4. So we should not forget the information we have for alpha and lambda. So we've seen that mu is equal to minus 2, lambda is equal to minus 3, and alpha is equal to 4. So we already got the A. This is C, sorry, I just forgot. So the position vector of the point of intersection. So now I know this, I just have to substitute them inside. Usually it's best to try in both of them to make sure that the position vector is the same for both of them, otherwise you've made an error in the process. So I would look at L1. So you looking at L1, my error will be equal to I minus j plus 3k plus lambda is minus 3. So I'll take minus 3, so just put minus 3 there, times I minus j plus k. To fix it, well, this is I here, minus j plus 3k, minus 3 times that is minus 3i, minus in there is plus 3j, minus 3k. If you fix it properly, this is I, minus 2i is minus 2i, minus 3i is minus 2i. This and that gives me plus 2j. And this disappears, the k disappears. It's good to also make sure that it is the same in equation 2. So this is R is equal to 2i. We know alpha is 4 plus 4j plus 6k. And then we are using mu. Mu is minus 2 into 2i plus j plus 3k. So here, let's fix it as we said before. So this is 2i here plus 4j plus 6k minus 4i minus 2j minus 6k. So 2i and that is minus 2i. 4j minus 2j is plus 2j. 6k minus 6k is off. So you see they are the same. So this is the position vector of the point of intersection of the two lines. So the last one says that we should look for the cosine of the angle between the lines. I will just write the formula. I will not go further to describe it, just to tell you how it works. So if I have two equations of lines, let me say A here plus lambda v and the other b plus lambda u. We call this, I'm told to look for the angle between them, the cosine of that angle. Then the cosine of the angle is actually the cosine of the angle between the direction vectors. So only the v and the u come into play. In that case, the cosine of that angle, theta, will be equal to dot u all over the magnitude of v, magnitude of u. So in our case here, if we look at this case, this will be, take this vector, the first one is I minus j plus k, dot product with 2i plus j plus 3k divided by the magnitude of times the magnitude of 2i plus j plus 3k. If you do this, you come out with a number, and if you, they'll just have to look for the cosine of that angle. So cos theta of the angle should give you some information you just feel. Remember that how we do dot product. I think you also know that as well. I dot I is only one that survives because I dot I is 1. I dot j is 0 because they're perpendicular 90 degrees, and cos 90 degrees is 0. So only I and I survive, j and k. We will look at some other videos where maybe we have much more time to do. Thank you, and remember to subscribe, share with your friends, thumbs up.